In a previous video, we had a look at 5 different Linux commands, and we tested those in a Ubuntu distribution. These commands are commands that we can install and we have tested, and they basically should work with Debian distributions, but also with different Linux distributions as well, perhaps with different package managers. We installed our commands back then with apt. In this video, we are having a look at 5 different commands. 5 different commands that perhaps they are not very well known, perhaps you don't know them very well, perhaps you haven't heard of them, maybe you have, and if you have, let me know in the comments what you think of them after I talk about them in this video. And so the first command we are having a look at is called fuser or fuser. And fuser is an interesting command because it allows us to see which processes, which process IDs are using a certain file. It is an interesting command because we can make a distinguishment between what it is to run a command and what it is to run a file from that command, specifically Java and a jar file. That is where we are going to apply fuser in our command line. So let's see one example of that right over here. So if we go to this folder, this is the root folder that I have, but if you can try this anywhere in your system, but I will just choose one particular project that I know that runs as a jar file for a Java application. So for example, if I go to the master test drives project that I have, and then inside of it I go to the validation company, then I have already a pre-built jar that is a runnable jar, and we can find it in build and then libs, and then there we should get a dvalidation company.jar. So we've got this jar file that we want to run. Of course it says permission denied because I tried to run it directly from the command line, and that of course does not work. If we now use java -jar and then run the build libs the validation company.jar, we should then get our application running. But what we also want to do is to make sure that it runs in the background. So we just add an ampersand at the end like this, and this will now run it in the background. It doesn't matter if it's going to influence our command line because we aren't going to do anything that is going to affect that. It will just keep the application running in the background to do some tests with fuser or fuser. If we use fuser and do -v, or let's just start first with just using it directly, and then go build libs and then the validation company.jar, we can see that immediately tells us the location of that jar, and we see that at the end there is the process ID. Doesn't seem like a lot of information. It's only the process ID. Well, if you are used to using PS, the process snapshot, you also know that you can use it to find out the process ID of a certain thing that you are looking for. But in this case, we are sure that we are running the validation company.jar. We can also run fuser and then say verbose. And then we get this extra information. What is important here is that when we run fuser -v, we are getting a lot of information. And one of the things that will tell us is if the files are being executed or if they are simply being opened or anything else. If we look at the manual of fuser, we can see that fuser is an identify processes using files or sockets command, and it says it will display the process IDs of processes using the specified files or file systems. In the default display mode, each file name is followed by a letter denoting the type of access. That's what we see there. If you notice, there's an F. And F here does not mean current directory because that's with a C, and E is executable being run, and F, the one that we saw in our result of the command line, is open file. F is omitted in default display mode. And we see other things, file open for writing with uppercase F, the root directory with R, mapped file or shared directory, and a placeholder omitted in default display mode. What's important here is that we understand also, let me just quit this, that in the end there's this thing here called Java. And Java tells us something, that this file is being opened by Java. we've got already the process ID, which is 53995. But here's the interesting thing that I find about fuser. With fuser, you can also see that the Java process is also running. And to do that, we need to find out which Java have we started. And of course, we started this Java process from our Java home directory. So what we can do now is first see where our Java home directory is located. So if we echo it, we can see that it's located on the SDK manager folder and the current candidate folder specifically. What we can also do is issue fuser-v, and then instead of the jar file, we can then specify the home folder and the location of the Java command. So we can just say java home /bin/java. And if we do this, we will see the detailed information about the process ID. We can see that it is also 5399 as just here 53995, 53995. And we can see that it's being run by Java, and this is also being run by Java. But of course, this makes sense because Java is the process that is running it. But we can see a small difference here. This one has an F to it, and this one has an E to it. These attributes tells us that in the first case, the jar file is opened by the Java process, and the E here tells us that Java is the executable that is running the jar file. And this also allows us to make a distinguishment between what it is to run an executable jar file and what it is to run Java. They both run together. Java will run our jar file by opening the file and then interpreting what's in that jar file to run it in our JVM, which is run by this command, Java. So this is fuser. Now, there is another kind of command that can help us doing other things that it's important for our development. If you are doing development, if you are doing code, or maybe if you are just doing some kind of README file or an XML file, or even a simple text file may be useful. Maybe we want to compare different versions of different files. And to do that, there is a very simple command, but very efficient one in Linux, that is called comm. Now, comm, the command comm, comes out of the construction of comparison and two different files. At least allegedly, that is as far as I could find, that's where the two M's come from. So it's C-O-M-M. And comm allows us to compare files, but it is a command that when you use it for the first time, you will see that it doesn't seem to do a lot. It doesn't seem to be very useful because it's not very clear and it seems very cumbersome. However, there is a lot of potential for this command, and that is what I want to show right now. So let's have a look at that. Comm, we can use it in many different files. I will use it specifically for a README file, and specifically for a README file that I created in this project, JE or Cloud Test Drives. The links will be also in the description. And here I have created one file, top Linux commands. This is the original one, and I just copied another file to it, which is called top Linux commands 2.md. And the only difference is the one we see here with IntelliJ, group 1 and group 2. So there's just one I as a difference between the files. So now in the command line, let's go into that folder, and that one is located in JE.org Cloud Test Drives. And here we've got the two different files. We've got the top Linux command 2, top Linux commands. We are going to compare these two. At least we are going to make tests between the two of them. Now for this, we need to do comm, and then we can specify top Linux commands md, and then top Linux commands 2 md. And we get all of this text, and it seems very cumbersome, and it's difficult to interpret. So let's first, before we start reading what's in here, let's check the manual and see what it says. If you go to man comm, we've got here that it is a compare two sorted files line by line command. But it is an interesting one because it doesn't show this in a human readable form. It is weird because it shows in the first column the lines that are unique for file 1, in the second column the lines that are unique for file 2, and then finally the lines that are common for the two files. what happens here is that what we see in our command line is something like that, but it's difficult to read because we've got all of this text here and it seems to be mixed. And further, it says file 1 is not in sorted order and the other is also not in sorted order. What's important here is that we understand that the comm command works on the basis of comparison line by line, and therefore it is important to have the files sorted in a way. And when we think about that, we may think that, oh, this may not be very helpful, but it is. Let's have a look at why do I say that. The thing is, if we use this comm just like this, perhaps it's difficult to interpret, it's different to parse, it's different to understand what's going on there. But here's an interesting bit. If we do dash and we do 1, 2, 3, for example, what this will do, it will ignore all the different columns. And so we are not going to get anything, except that our files are not in the sorted order and that the input is not in the sorted order. We don't get anything. But what this 1, 2, 3 means is that with 1 we are ignoring column 1, with 2 we are ignoring column 2, and with 3 we are ignoring column 3. That means the differences in file 1, the differences in file 2, and the common lines in file 3. If we simply run, for example, 2, 3, if we are ignoring columns 2 and 3, we will only get column 1. And look at that. It says group 1, only group 1. Now we know from the command line that there is a difference and that file 1 differs from file 2 with this line group 1. That is the difference between the two files, and the whole line is shown. Not the specific difference, but the whole line. But we still get the file 1 is not in sorted order and file 2 is not in sorted order. What we can do, if we go to the manual, we can see that there is an option, no check order. We can also go here and say, let's not check the order. So let's go, no check order. And if we do that, we get the specific line, which we now can use to tell some process, something that we are doing with a shell script, that we found one line that is different in which line that is. We can also do that for the second file. Where does the second file differs? Then we are ignoring column 1 and column 3. And if we want to check where are they exactly the same, then we just ignore columns 1 and 2, and we get the full similarity without the specific line. So if we go back to our IntelliJ, we can see that we've got a line above which is called commands are listed, and under the line difference we see TLDR. And if we go here, we see that exactly that the line that is different is not there. Now there are multiple uses to use this command, but we may want to, for example, see the lines that are attributed to the differences. What we can also do here is yet another thing. It's a sort of a trick that we can use combined with comm, and that is a simple one. That's just saying, hey, I want to see the differences in file 1 in regards to file 2, but I also want to see the line number. So what we can do is simply this. There's another command called number lines, and the number of lines command can give us the number of lines per file. So this means that instead of using just the content of top Linux commands MD, we are going to prepend each line of the content of that file with the line number. So if we use that in this one over here as well, then we can say that we are reading both files with the line numbers prepended to each one of these lines. BA in this case means B is the body of the file, the whole body, and A means all the lines, including white spaces. So if you run this now, we've got that on line 5 of file 1, there is a difference in regards to file 2 that contains the text ### space group space 1. So this is comm. Comm is a very interesting command for comparing files if you want to make shell scripts. It is very interesting. It is not as handy as using things like the file comparer in an IDE, like for example what we just saw on IntelliJ, but it can be very useful if we want to make automation, which is also a part of making development and creating systems that do things automatically for us. The third command that I want to show you is a command that I'm not entirely sure what applications it could have, but it's interesting to know. We may think of it as something to be used perhaps in a game, or perhaps where we want to generate random content with some kind of text source. It's called shuf, and shuf comes from shuffling, of course. And shuf means that we are going to use this command to shuffle lines of that file. And shuffling lines of that file can be used in many different ways. There are different switches for this command, but it is an interesting one to have a look at because it may be worth knowing that it exists, and we may want to use something like that in automation. So let's go back to the place where we were in JE or Cloud Test Drives, and there let's just first make a list and do a cat of top Linux commands. By the way, cat means concatenation, if you don't know that. Now, we've got the whole text of the file. Now, if we apply shuf to this file, we can see that all lines have been shuffled. No line or text has been changed. They have all changed location. So they are now in different places in our file. It's also interesting if we run this with NL. So if we run this with the number lines command, and then we see the result of it, we can see that it shuffles the line numbers as well. And we can see that all the text has been changed and the lines have changed order in the result. But we can do other things with shuf. So if we look at the manual, man shuf, we can see that it's got different options. It's got echo, it's got input range, it's got a head count, it's got the output file if we want to save this to a file, the result, if we want to get some random source bytes from another file, if we want to repeat the lines. This is an interesting one. If we just use -r to our text, it's going to keep generating random lines forever. It doesn't stop. I don't know where would this be useful. Perhaps if we are making tests, for example, and we want an endless source of random text, this could be useful for that. So this could be useful in automating tests, for example. Not for this specific test file, but if we are making some kind of text-based text processing program, then perhaps this could be useful to automate tests. Another one that we've got here is the head count. And head count has also an interest use. We are going to try just that one before we move on to the next command, the fourth command. If we go over here and say head count, just add head count and then let's say 4, it will just print out the 4 first lines of whatever we configure the command to be. In this case, we said that we want to repeat. So perhaps if we, this is one example. So it keeps repeating lines randomly. And now we've got in the first 4 lines that have been generated 2 equal lines because it will pick them randomly to generate an output that we can then put out to a file. Let's try that one as well. We have seen that that was, I think, output file. No, let's check again. Shuf -o. So that's an interesting one. Go -o or -o. Then we can say output.text. .text. If we do that and we do a cat output text, then we see that that is the result of our generated text. All right, so the fourth command on the list is another weird one, and it's also probably not very well known. It's called tack. Think about it, tack. What does TAC sounds like? T-A-C. If you guessed cat, you're right. It's the reverse of cat. It's the reverse of concatenation. And now let's think about it. What does the reverse of concatenation could possibly do? Perhaps what you just thought, perhaps not. But if you thought that it is reverting the text, it is reverting the text. That's exactly what it does. We can see the context of a file or concatenate context of a file in a reversed order. How does that reverse order occurs? That reverse order occurs per line. So that means that we will get the text reverse, not the reversal of each individual line, but the reversal of the text. So let's see what happens when we run TAC in these experimental files. If we now run TAC on the top Linux commands file, the original one, we see that it's completely reversed in terms of lines. So it starts out with the last line with the button to go back, and then it shows the different lines of the different commands for group 1. By the way, this is group 2, this video, and it finally presents group 1, where we saw the difference between the first file and second file, and then all the commands listed are used in Linux, blah, 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 and then at the end, we've got the title of the README file. So this is TAC cat. And on that note, the last command we are looking at in this video is called bat, B-A-T. Bat in Debian distributions is called batcat. And batcat, I tried to find out where does the name batcat comes from. Apparently, it comes from bat, some kind of analogy to a bat, to an actual bat, because a bat has very different systems of echolocation. They can detect things, they can detect sounds, they have an ability to visualize in a different way, and they are usually very, very sharp animals in that sense. They can hunt very well, and the analogy is made because batcat allows us to visualize text, but not in a usual way, not in the way that we are used to. And for developers and programmers, this is one of the best things that we could use in the command line without the use of an IDE. Let me explain that. Batcat allows us to visualize text with highlights. So let's have a look at that. If I go now out of this project and I go to, for example, a very simple project, this one, which is at this moment, probably this is a project that I should move to a module inside of a Kotlin development or example project, but it's still in a separate project. If we look at it from the source files, if we go to the source main Kotlin, and then here we find json2builder.kt. This is a Kotlin file. If we want to see the contents of this file in a very easy way from the command line, we normally just do cat. And that's usually something that we don't want to do even in the command line. We always want to use an IDE to read code files, source code files. Then, of course, we are limited to our command line. And so sometimes we wish there was something else that we could use instead of just a cat, for example. Or if you want to use that Vim, you could maybe use that and try to see something there. There are ways to use Vim with highlights. But that's not the one, that's not an ideal situation. We can use batcat for these cases. If we use batcat, the most interesting thing that I find about this command is what we are going to see right now. If I run this, we will see the whole file not only highlighted, but also with the lines of code. And we can read this file just as we would read it in an IntelliJ or in an Eclipse or in a NetBeans or whatever. We can read it just like we read in those IDEs. Those highly sophisticated IDEs look pretty much like this, except that they sit in a graphic user interface. But further than that, it's just this. Now, of course, we don't have IntelliSense, and of course, we don't have autocomplete, and of course, we don't have options, we don't have refactoring, but if we get limited to this situation, we can still see the code in a highlighted way, which will definitely improve the way we read code with this command. And we can use it with other different things. If I go here to this folder, I'm pretty sure I've got other different files. If I go to the root, for example, a make file, do we have a make file? Yes, we do. So if we just say bad cat and then make file, we see everything highlighted. And we also have the benefit of using more. Look at that. We can just go up and down the file and we can just read it, and we can perform searches. Let's search for depths, for example, and then it goes and it highlights all the depths that we want to see. And we can go up and down the file and just see anything we want to see and just read it, because we can notice already that this is highlighted. This is one of the commands that we can run via a make file, and we've got an export which is highlighted with this pink, purple color. These are definitely in purple, which are variables. For example, this switch-s, everything is highlighted in a way that we can immediately read the file, and it is much easier to read. Badcat also provides support to other different files. If we go badcat, for example, settings, this is a properties JSON-based file, and it does show that. It shows the first property, JSON2builder pattern. That's the name of the project. It doesn't matter what it does. At this point, we can also see, for example, why not the Gradle build file? Let's see what it highlights with the build Gradle file. Let's see build Gradle, and then we can look at it, and it's probably not the best highlighting ever, but we do see that it has highlighted the group name, the version name, the set, so the method name, it has also highlighted. We've got these dots all with a different color, with a red color. And what further can we see here? If we go further down, we can see that the JVM toolchain is also highlighted. So in this case, we are using the JVM 21. And further, there isn't much more. Let's have a look if we can find another file that we perhaps find it also interesting. For example, a bat file. The bat file, which is a batch file that we can use in Windows, not in Linux, but let's try and see if it will work well with a bat file. Gradle w.bat. And it works perfectly. We can see that we've got all of these REM lines. These are just basically comments in batch. And we can see the for loops, we can see the echoes. Everything here seems to be correctly highlighted, or at least in a way that we can easily read what's in there. Of course, these are automated files generated by Gradle, but we can still try to read what it does. And we can see very well that, for example, here Windows NT, we've got here the switch D or Gradle app name. So we've got everything pretty nicely highlighted, and we can use this from the command line. So we had a look at Fuser, at comm, with number lines. That's 2 in 1 command. Then we had a look at shuf. Then we had a look at cat. And then finally, we had a look at badcat. So we actually had a look at 5 different processors and visualizers and 1 single process analyzer and inspector. All right, everyone. So these were 5 commands that I wanted to show you. Actually, we had a look at 6. Only 2 of them were combined in 1. And I hope these 5 different commands were useful for you. And I hope that you now feel that you have more tools available to you and that you eventually remember these commands to use you when you actually need them. If you enjoyed this video, please make sure to give us one big like. Don't forget to subscribe to this channel to learn more about software development and systems and anything related to IT. Make sure to read the description. I will put there the sources, and as usual, we'll put all the important information about this video and the topics that were discussed in it. And of course, I would love to hear your comments. So, until the next video, make sure to stay tech, keep programming, be kind, and have a good one. Bye.
As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.